Today we are going to look at lesson 3 from our unit on polygons. Today's lesson will focus on interior angles of a polygon. What is an interior angle? Well, ignore math for just a second. What do you think interior means? When you hear the word interior, what comes to mind? Hopefully it means in your brain inside, like interior paint goes on the inside of a house. It's the opposite of exterior. Exterior would be outside. So an interior angle, putting it in math terms now, is an inside angle. So an interior angle of a polygon is an angle inside of the polygon, and there's one at every vertex of the polygon. So you can see there in the diagram, we have all those different colors, each one of them being a different interior angle. Interior versus exterior. So you can see in the diagram, you have two different types or two different colors even of angles that are identified there for you. The interior angles are the ones in red. They are the ones that are inside of our polygon. And the ones on the outside are blue. Those are the exterior angles. They're on the outside of the polygon, but they are formed when we take one side and just keep it going, just extend it out. That's how you make an exterior angle. We will talk about those later, just not right now. Right now, I want you to focus just on those red interior angles. Now, the sum, remember sum means add them up. The sum of the interior angles of a polygon has its own special theorem. It's called the interior angle sum theorem. So I want to explain that to you. So you've already learned that the angles in a triangle always add up to 180 degrees. So we're going to use that to find the sum of all of the angles of a polygon. So you're going to start at one vertex. In this case, I have a red circle there. And you want to make a line to every vertex that will form a triangle. So obviously, I can't go from this red line over to this vertex. That black line is the side of the shape. It's already there. So I can't do that. But I can go from here to the next vertex, and here down to the next one, and here down to the next one. But I can't go again right next to it, because I'd be tracing over the top of the side of our shape. So we have those three lines drawn in there that formed our triangles for us. The next thing we want to do is count those triangles. So we can see there are 1, 2, 3, 4 triangles there. And every one of those triangles is 180 degrees. So 4 times 180 is 720 degrees. So all of the angles of this hexagon would add up to 720 degrees. Now, a hexagon's not too bad. Drawing in 3 lines and counting 4 triangles, not that big a deal. But what if you have a 30gon? How many triangles are you going to create then? What if you have even just a 20gon? What if you don't have a picture and you're just asked to find something? How are you going to do that? So it's not always easy to draw those in, so we really need a pattern or a formula or something we can do that's different. So let's take a look. We have here on the left a quadrilateral. It can be broken into 2 triangles. A pentagon is broken into 3. The hexagon, which is what we just did a moment ago, is 4 triangles. The heptagon is 5, and the octagon is 6. So maybe if you look at it in this format over here with table, here's our number of sides, and then here's our number of triangles. Do you notice a pattern? I'm hoping you do. Hopefully you saw the pattern was the number of sides minus 2 gives you the number of triangles. In other words, the number of triangles is 2 less than the number of sides. Now, why does that help us? Because we know that we can take this number of triangles and times it by 180. So as long as we know the number of sides over here from this column, we can just subtract 2 and then times it by 180. So that's what gives us our formula right down here in bold on the bottom. The number of sides minus 2 times 180 is how we will determine the sum of the interior angles. So I have 4 examples for us. The 14gon would have 14 sides. So we're going to start with 14 minus 2. That gives us 12, and 12 times 180. So all of the angles of a 14gon are going to add up to 2,160 degrees. In a 20gon, so a 20gon has 20 sides. So we'd start with 20 minus 2, which is 18. 18 times 180 is 3,240. So all the angles of a 20gon would add up to 3,240. Letter C, a heptagon. Hepta is 7. So 7 minus 2 is 5. 5 times 180 is 900. So all of the angles of a heptagon are going to add up to 900. A quadrilateral. Quad means 4. So 4 minus 2 is 2. 2 times 180 is 360. So all of the angles of a quadrilateral are going to add up to 360 degrees. Now, these are true whether the polygon is a regular polygon or irregular. It doesn't matter. The angles are still going to add up to these amounts. But something else is true if we have a regular polygon. So if that polygon is regular, remember, regular means all angle measures are the same. So we can know what each of those angle measures are going to be specifically if we calculate the sum and then divide by how many angles there are. So let's just do a couple of those. Here we have the regular octagon. So an octagon has 8 sides. So we would start with 8 minus 2, which is 6, and 6 times 180 is 1,080 degrees. So all of the angles in the octagon are going to add up to 100 or 1,080 degrees. There are 8 angles in an octagon. So we're going to take 1,080 and divide it by the 8 angles, and each of the angles will measure 135 degrees. Looking at example B, it asks for a regular decagon. A decagon has 10 sides, so we're going to start with 10 minus 2, which is 8, and 8 times 180 is 1,440 degrees. So all of the angles are going to add up to 1,440 degrees. And because it is a decagon, it means there are 10 of those angles that are all the same. So we would take 1,440, divide it by 10, and we would get that each of those angles, all 10 of them, will measure exactly 144 degrees. In your assignment today, you'll be looking at the sum of the angles of those polygons, and you'll be also telling me the measure of some of them in a regular polygon. And then I have an extension question or two in there, but there is some information to help guide you as you work through those. So let me know if you have any questions. As always, I am more than happy to help you. You just got to let me know that you need the assistance.